Hey College Algebra, in video of the week number 9, I'd like to talk about polynomial long division and synthetic division. You're going to be doing a lot of this over the course of the next chapter. And this might seem a little bit goofy, but I'd like to remind you first how to do regular old long division. So you have 221 divided by 3. You ask the question, how many times does 3 go into 2? The answer is it doesn't. You ask how many times does 3 go into 22? The answer is 7. You multiply that 7 by the 3, and you get 21. Don't forget you subtract, and when you subtract, you end up with a 1 here. You bring down the next number in the list. You ask how many times does 3 go into 11 in this case? The answer is 3 times. You put that up here. You multiply 3 by 3 to get 9. You subtract again, and you end up with a remainder of 2. And in a lot of cases, what you'll do with that 2 is you'll divide it by the original divisor, and that's your answer, 73 2/3. Okay, we're going to do that same process, except we're going to use polynomials. So we're going to do x cubed plus 2x minus 5 divided by x plus 3. I set up my long division problem just like we would have with numbers. The only difference is you'll notice I put a placeholder here for my x squared term. There was no x squared in this polynomial. I want to make sure that I have an x squared term in here just for space purposes. So I'm going to put in a 0x squared right here. Okay, so I'm going to ask the question, how many times does x go into x cubed? And the answer probably seems a little bit funny at first, but the answer is x squared times. You'll see in a minute what happens. We're going to take this x squared and we're going to multiply it by the x plus 3. And when we do that, we get x cubed plus 3x squared. Just like with regular long division, we're then going to subtract. X cubed minus x cubed is 0. 0 minus 3x squared is negative 3x squared. And I'm going to bring down the next term. Then the next question we ask is, how many times does x plus 3 go into negative 3x squared? The answer is going to be negative 3x. We take that negative 3x, we multiply it by this x plus 3 out here. We're going to get negative 3x squared minus 9x. And don't forget we are subtracting. Negative 3x squared minus a negative 3x squared is 0. 2x minus negative 9x is 11x. And we're going to bring down the next term. We're going to ask the question one more time. How many times does x plus 3 go into 11x minus 5? The answer is 11. If we multiply that 11 by the x plus 3, we get 11x plus 33. Don't forget, again, we are subtracting. Negative 5 minus 33 is negative 38, and that is our remainder. So negative 38 is the remainder. And this guy up here, this x squared minus 3x plus 11, that's our quotient. So I want to write out what we just did. What we did is we took x cubed plus 2x minus 5. We divided it by x plus 3. And what did we end up with? We ended up with our quotient, x squared minus 3x plus 11. And we got this remainder of negative 38. And just like before, what we can do with that remainder is we can divide it by the original divisor in the problem. And by doing this long division, we came up with this true statement. Those two polynomials divided by one another ends up being this quadratic polynomial plus this remainder. I do want to show you one more way to write this, because if we think of multiplying both sides of this equation up here by this x plus 3, what's going to happen is you're going to have the x plus 3 times that quadratic, the x squared minus 3x plus 11. And if you take that x plus 3 and multiply it times this term right here, the x plus 3's cancel and you're just left with the remainder. This is another way to write out what we just did. Now I know for sure that there's one homework problem that asks you to write out your answer like this, and there's another homework problem that asks you to write your answer out like that. Okay, that's the basic process of polynomial long division. What I want to do is I want to show you how to do the exact same problem, just using synthetic division. The way we set up this problem with synthetic division is we write out the coefficients of our numerator first. So the coefficients of our numerator, we have 1x cubed, we have 0x squared, 2x, and negative 5. What goes in the box might seem a little bit mysterious at first, but if you look at the end of the last video of the week, I told you that if you had a factor of, say, x plus 3 in a polynomial, the associated 0 for that polynomial would be x equals negative 3. And that's the number that we're going to put into our little box. Let me scroll down a little bit and I'll show you the process of synthetic division. It's actually the exact same process as long division, except we're not writing out all the x's. We're just going to drop our first term down. We're then going to take whatever we have in this bottom row and we're going to multiply it by what's in the box. What's in the box is -3 in this case. So 1 times -3 is -3. Then we're going to add. In this case, we have 0 plus -3. That's going to give us -3. Again, we're going to multiply that number in the bottom row by what's in the box. -3 times -3 is 9. We're going to add 2 plus 9 is 11. We're going to multiply that number by -3, and we're going to add -5 plus -33 is -38. Now these numbers might seem a little bit familiar to you. And if you study the long division process, you'll notice that what we did was the exact same thing as long division. This is just a much faster process. You'll notice what we're left with here. We have 1x squared minus 3x plus 11 with a remainder of -38. That's the exact same thing that we got in the problem above. Okay, so synthetic division, long division can basically do the same things. The thing is that synthetic division only works when we're talking about dividing out what we call a linear factor. That's a factor with just an x to the first power in it. If we had something like x squared plus 3 and we had to do this division problem, the only way to do the problem like this would be to use the polynomial long division technique, because synthetic division wouldn't actually work. So I think of synthetic division as a shortcut whenever we're dividing by a linear factor, but you still have to learn how to do the long division process above. Okay, let's keep this video rolling. Let's try this problem right here. Because it's such a fast process, I'm going to use synthetic division. I'm going to put a 3 in the box because our factor here is x minus 3, and that associated 0 would be x equals 3. We're dropping down the 2. We're going to multiply the 2 by what's in the box, and we're going to add. We're going to multiply the number in the bottom row by what's in the box, and we're going to add. One more time, we add, and this time we get a remainder of 0. So what did we just learn about this problem? Well, we learned that if you divide these two polynomials here, you're going to end up getting x squared minus x minus 1 with no remainder, so you don't have another term over here. Getting a remainder of 0 is actually a really big deal, because what it says is that x minus 3 divides evenly into the polynomial numerator. Now if we take this thing right here and we write it the other way, in other words, we think of multiplying this x minus 3 to the other side of the equation, what we learn is that we just took this 2x cubed minus 7x squared plus 2x plus 3 polynomial, and we factored out an x minus 3 using long division. So 0 remainder is actually a really big deal here. It means that x minus 3 divides evenly into the polynomial that we're given in the numerator. It means that x minus 3 is a factor of 2x cubed minus 7x squared plus 2x plus 3. And we know from the previous video that every time we have a factor of a polynomial, we automatically have a 0 of a polynomial. So in this case, we learn that x equals 3 is a 0 of the polynomial that was up in the numerator here. That is a lot of information given to us just because we got a 0 remainder. It's really great. And you know, right now I'm noticing that I did not copy my coefficients over correctly. So those 3 coefficients are supposed to go right here in this polynomial. It looks like somehow I forgot to put a 2 there. This 2 also needs to go up into this polynomial right here. So sorry about that. Okay, so if this was your problem, if this was your polynomial that was given and you divided out this factor x minus 3, part of the process of learning something about this polynomial might be to continue to factor the polynomial. In this case, we could continue to factor this trinomial right here. In this case, we're going to factor just like this into 2x plus 1 and x minus 1 factor. Now, if we were able to do all this stuff, we would have learned a lot about this polynomial right here. We know its end behavior. You'll remember I talked about end behavior in video of the week number 8. Based on its degree and its leading coefficient, we know the basic shape of this polynomial. And now that we've factored it out, we have 1, 2, 3 zeros of that polynomial. So at this point, we have a really good idea of what this whole polynomial looks like. Okay, I hope that helps you with a bunch of your homework problems. If you have any questions, let me know. And if not, I'll see you all in the next video.